Alright, so in this video, we're going to look at the sum of infinite geometric series. So notice in our syllabus that we only have infinite sums for geometric series, and otherwise we've got finite for arithmetic. And we're going to look at why that is in a bit. So let's start with this example. So you're moving towards a doorway that's 8 meters away. So our doorway, we're going to put down here is the doorway somewhere around here. But at each move, you go half the distance between you and the doorway. So your first move is 4 meters, and then 2 meters, and then 1 meter, half, a quarter, an eighth, a 16th. So these slices in here are going to keep getting smaller and smaller and smaller. Every step you're moving half the distance. So the question is, after 5 moves, how far in total have we gone? So if we've moved 5 times, then we've got our 4 plus 2 plus 1 plus a half plus a fourth. So 7.75 meters. After 10 moves, well, that's going to be our sum of 10. And we've got our U1 and R to the n minus 1 over R minus 1. And we're going to get, let's see what we get, 4 times a half to the 10th minus 1, divide by negative a half. 7.99 approximately. And after 100 moves, if you keep thinking about this, like already we're here, a quarter, an eighth, a 16th, we're going to end up getting so close to the door that our nose is going to be touching it, but there's still going to be infinitesimally small distance between us and the door, but our feet are going to be too big that we're not going to make it. So after 100 moves, we're going to have gone approximately our 8 meters. So if we keep going this way forever, infinitely long period of time, will we ever get to the door? Well, we're going to be close to the door, so close that we would be touching it, but there would always be a slightly smaller, and we're going to get into like nanometers smaller distance that we could go, but we're not going to go an infinitely long distance. We're not going to go through the door. So will we ever get to the door? No. But simultaneously, our distance isn't infinitely long either. So let's think about our general formula for sum of n terms of a geometric series. That's going to be u1 times 1 minus r to the n over 1 minus r. But now, in this case, our r was a half. So let's think about our limit as n goes to infinity of a half raised to the n power. Well, as we said, we get a half, a quarter, an eighth, a 16th, a 32nd. It's going to get so small that it's going to become approximately 0. So that means this disappears. So when we have a sum to infinity, we have u1 times 1 minus 0 over 1 minus r, which of course just turns into u1 over 1 minus r. So in the case up here, if we looked at our sum to infinity, 4 over 1 minus a half is equal to 8. So that's what we said, that we would go approximately our 8 meters. And so here, as in your formula booklet, we have a general sequence. Notice though, our general formula, notice that the r value though has to be between negative 1 and 1, because this is the only situation where our limit as n goes to infinity of r sub n, that goes to 0. So then this term goes away and we end up with this.